So yesterday we learned about the mole concept. Now, here's my question. The whole purpose of learning about the mole is so that we can take atoms, which are too small for us to count, or rather we are too big to count them accurately, and to make it practical for us to actually work, thank you very kindly, to actually work with them in a lab. Does that make sense? So the whole point is we are very large, so counting out individual atoms is impractical for us. So we want to work with large numbers. And so the mole is a really big number. 6.02 times 10 to the 23rd, it's a lot. Having said that, am I going to sit there and count out 6.02 times 10 to the 23rd atoms? First of all, we determined yesterday it would take how long? How many years just to count that high?
1 million. Like, it's like three, you said a million 3 times and a billion once.
Yeah, so a million times a million times a million times a billion years, just to count that high, if we could say a number every second. So are we going to count that high? No. So obviously, at no point in the lab am I going to expect you to count out 6.02 times 10 to the 23rd. Good morning, individual atoms.
You have a lesson?
It's a whip, actually.
It's a whip.
Yes. I've got a leather jacket over there, but it's quite warm. I roasted the pumpkin seeds yesterday, and I forgot all about them. And then my smoke alarm went off at like 1 a.m. That was fun. Yeah, good times. Anyway, shh. So listen, this is the key to the whole thing. This is the linchpin. This holds it all together. Very important. Why this random number, 6.02 times 10 to the 23rd? Why use that number? We could have used any number. We could have used a round number, right? If we wanted to go that big, why not 1 times 10 to the 23rd, right? Why not pick a nice round number? Why 6.02? I think it's actually like 6.0223, blah, 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 whatever. It's this big, long decimal place. Why not just say 1 times 10 to the 23rd?
Help with, like even on Halloween, they don't want to stay away from the class.
Right.
To help with like sig figs.
Sure, but we could have said it was defined as exactly 1 times 10 to the 23rd, and then it would be infinite sig figs. That'd be even better. So why pick 6.02? It's a weird number. Why would we pick that number? Well, it actually comes up with this. It starts with a scientist. What was his name again? Avogadro. Asking a question. And you know what, when you think about it, it's a pretty clever one. He said, you know what? Hydrogen weighs 1 atomic mass unit. We've determined that by definition, right? It just has one proton. Proton weighs 1 atomic mass unit, so hydrogen weighs 1 atomic mass unit. And he just said this. How much hydrogen would I have? Now, I can't weigh an atomic mass unit, right? There's no scale that will weigh that. That's an incredibly, in fact, it's the lightest atom possible. I can't weigh it. So he just said this. He said, I can't weigh out an atomic mass unit of hydrogen, but I could weigh out a gram of hydrogen, right? I could take a balloon, put it in a vacuum chamber, and fill it with hydrogen gas till it weighed a gram, right? And then I would have 1 gram of hydrogen. So he asked the question, well, wait a minute. If I did that, how many atoms would that be? Why would he pick 1 gram? Small amount, but it's in terms of atoms, it's a large amount. It's on our scale. But the other thing is, why would I pick 1 gram for hydrogen?
Because hydrogen is it has the smallest weight for it.
Sure. But not just that. 1, specifically, it weighs 1. The nice thing is this. If he figured out how many atoms were in 1 gram of hydrogen, he would know exactly how many atoms were in 12 grams of carbon, right? And he would figure out exactly how many atoms were in 16 grams of oxygen. And he would know exactly how many atoms were in 32 grams of sulfur. Because if he figures out how many hydrogens it takes to weigh 1 gram, what he's really found is a conversion factor. A conversion factor from atomic mass units, which are tiny and we can't weigh out, to grams, which are Easy to weigh out, right? Whenever I get your labs ready, I go in the back and I take my scale out and I do a little bit of math that you will know how to do after the end of today. And I figure out how much I need in grams and I just weigh it into a beaker, right? I zero the scale, I put it on, and when I've got the right amount, I'm done. And the cool thing is I then know exactly how many atoms, not exactly, but I know accurately how many atoms are in that sample of mine. So Avogadro's number is a conversion factor. It's the weight conversion from atomic mass units to grams. Is that a little weird? Mm-hmm. Think of it this way. How many grams in a kilogram? Kilo? 1,000. Good. There we go. So that means this. If I figured out how much, say, an apple weighed, right, in grams, if I had 1,000 of those apples, it would be the same weight, but now in kilograms. Does that make sense? Right? And now that number 1,000 would work for anything. If I figured out how much a piece of paper weighs, if I have 1,000 of them, I would know its weight not in grams, but in kilograms. Does that make sense?
I can't assume weigh different.
Assuming they all weigh the same. Okay. Assuming they all weigh the same. So for example, if I'm the manufacturer who makes these, right, and I weigh this on a scale, and I know its weight in grams, this is true, by the way. If you think about it, it has to be true. If I know what this weighs in grams, I know exactly what 1,000 of them will weigh in kilograms, because 1,000 converts from grams to kilograms. 1,000 grams makes a kilogram. So if this is 200 grams, 1,200 grams will be 200 kilograms. Does that make sense? This is a little conceptual. It's a little weird. Here's a fun film. Let's do a little poll. Put your hand up if that made any kind of sense. Hey, I got a few. All right. Put your hand up if that made no damn sense at all. All right, I'll take it. That's pretty good. We'll get there. So again, it's heady. It is conceptual. Okay, it's weird. It's weird to think about. But I just want you to imagine this. We could do it another way. We know that there's 16 ounces in a pound, right? You picture that? Does everyone know that? Do you not know that? So like if you get like an 8-ounce steak, that's half a pound. Okay, you don't have to write this down. But there's 16 ounces in 1 pound. So if a steak weighs 8 ounces, again, you don't have to write this. If a steak weighs 8 ounces, 16 of them will weigh what?
8 pounds.
Very good. 16 steaks will weigh 8 pounds. Does that make sense? Because that number 16 becomes a conversion factor. Since there's 16 ounces in a pound, 16 of anything, whatever its weight in is in ounces, will be its exact weight in pounds. Does that kind of make sense? A little bit? Okay. It is weird, right? There's 1,000 milliliters in a liter, right? Okay. So say a can of pop is, how much is a can of pop? Is it 350 mils? Am I inventing that number? It's 350? Okay. So a can of pop, that's the word of, believe it or not. Yeah. A can of pop is 350 milliliters. So 1,000 cans of pop would be what? Would be 350 liters. Good. Because 1,000 converts from one unit to the other, if we have 1,000 of something measured at this unit, it'll just be the same number at this unit. So if you use the conversion factor as a counting number, you can have the same digits, but in different units. And that makes it really easy, because when we're done today, anytime we want to know the weight of something in grams, you won't have to do any math. You'll just look at its weight in atomic mass units on the periodic table. Does that make sense? So a mole of hydrogen will weigh what? By the way, you're going to want your periodic table out for this. That yellow one I gave you that actually has masses on it, get that guy out. You're going to want it. The yellow one does. Yeah, because the ionic one I gave you does not. And if you have to share with the person next to you for now, that's fine. Let me know and I can get more of those if anyone doesn't have them.
Lazy. This is just me being lazy.
Okay, so again, here's the rule of thumb. 1 mole of an atom weighs in grams its atomic mass units. So let's look up iron. 1 mole of iron will weigh what? Look it up on the... Yeah, I want everyone to look it up. Look it up and find the mass of iron. Yep. 55 point, I'm sorry, give it to me again. 8452. Great. Grams of iron. And I want to show that we can write this fraction either way, and it's still true. We can say 1 mole of iron is 55.8452 grams of iron, or we can say 55.8452 grams of iron is 1 mole of iron. It makes no difference which way we write it. Does that make sense? You can always flip a ratio and it's still true. But written like this, in grams per mole, we call that the molar mass of iron. Yep.
I can't see.
Oh, I'm sorry. I will get out of your way. So when we write it in grams per mole, we call that the molar mass of an element. So in this case, the molar mass of iron is 55.8452 grams per mole. But again, it sounds fancy. We get the molar mass just by looking at the periodic table. Does that make sense? Just take out the periodic table, because the whole reason we picked the number a mole is that 6.02 times 10 to the 23rd atoms of iron weigh 55.8452 grams, which means that we don't have to count out atoms. We just weigh out solid iron, and we know we have that number. Does that kind of make sense? Ish? I'll take ish for now. Now, again, with all the math we do this unit, we're going to do dimensional analysis. So what have I been given to start this question? What have they told us right in the question? I say they. I made the question. What have I told you in the question? Yeah, specifically, how many moles of iron do I have? Good. So I have 3.46 moles of iron. What does the question want me to know? Mass. And what unit do we measure mass in? Grams. So I don't want moles of iron. Where am I going to put that in my fraction? Yeah, so I'm going to get rid of moles of iron. And what do I want on the top? Grams of iron. And again, if you haven't put the units, you haven't done the question. If you haven't put the subscript telling me what that unit applies to, you haven't done the question. Form matters here. It matters a lot. And I promise you, when you get to really difficult questions, if you try to get lazy and just put moles and not say what it is, you'll get lost. All right? We're going to do questions that might be 8 steps, 10 steps. You're going to need to know what you're talking about, or you're going to make a mistake. Does that make sense? Okay. Now, what numbers make this true? I wrote it on the side for simplicity here. How many grams of iron make up how many moles of iron? 1 mole of iron weighs how much? 55.8452 grams. And I'm just going to set this up by saying we're looking for the mass of iron. Okay, so go ahead and do that. We should be on the order of like what, 180, 100, like 180, 190. grams? What are you getting, like 191? What is it? 193.22, blah, blah, blah. Okay, how many decimal places, or how many significant digits do I want? Why 3? Because this has 1, 2, 3, 4, 5. This has 6 sig figs. That has 3 sig figs. But this only has 1 sig fig. Oh, that's infinite. Why is it infinite? Yeah, it's a counting number. It's a whole number. Good. So yeah, the answer should have 3 sig figs. Very good. So what is the answer then if we are answering the 3 significant figures? 193. And what's the unit? Grams of iron. Very good, guys. Very good. And I like to highlight my answer, especially when the page starts to get a little cluttered like this. It's nice to make sure that your final answer is identified nicely, right? In chemistry, we tend to not spend a lot of time writing therefore statements. We're not quite as formal as math. Well, you always can write a therefore statement. If you like them, if you find them particularly satisfying, dig in. I'll even be way more likely to throw part marks at you if your answer's wrong, if you have a nice therefore statement. Seriously, shows some work. Does anyone have any questions about that? So if you know how many moles of something you have, you can figure out its mass as long as you have a periodic table. Because we know a mole of an element just weighs what? Any element, how do I find how much a mole of it weighs? Yeah? You look at the atomic mass, but what unit are we actually going to use if we have a mole of it? Grams. So whatever its atomic mass is, that same number, but in grams, that's how much a mole of that thing weighs. All right.
When you say a mole, you mean 1?
1 mole. Yep. Yep, 1 mole. And actually, that's a good thing to point out. I will very specifically say 1 mole. Do you want to do one more together, or do you want me to back off and let you guys try this one? You want to try it? Great. Try it out. Get started. If you're lost, put your hand up. I'm happy to work with you. Okay. Give me a sec. I'll plug this in while we wait. I'm sorry. Do we have to what? I want you to get in the habit of, on the left-hand side, writing out. Now, you don't have to necessarily write as a ratio like that. If you prefer, I will say that. What are we talking about? Helium? What is the molar mass of helium? Okay, there is a letter. When we talk about molar mass, we use an uppercase M. And that means molar mass. And I will write that on here. And what is it for helium? What is helium's molar mass? Great. And then what's the unit for molar mass always? Grams of helium per. It's grams per molar mass is how many grams are in 1 mole. Good. So if you're going to write it like this, you don't actually need to write the HE here because it's given in the M at the beginning, but you could say that. So you can write it that way if you like, or you can write it as a ratio. I tend to write it as a ratio because to me this helps me remember. If I say 4.00260 grams of helium is 1 mole of helium, the nice thing is now that looks like exactly what I'm going to plug into the question. You know what I mean? So I like writing it as a ratio, but those are both acceptable ways to show the molar mass. You can use the capital M to show molar mass, or you can write it as a ratio. I don't care what you use, but I do want you to get in the habit of writing that next to the question, because eventually you won't do it just for atoms, but tomorrow we're going to start finding the molar masses of big molecules, you know, like what's the molar mass of sugar and stuff, and you're going to have to do some rough work to figure that out. So it's good to have it written somewhere. Does that make sense? Okay. Oh, you don't even have to know. Sorry. We'll just on example 2. We need to example 1 momentarily. In fact, I'll put it up here if you want to copy it down, and then we can explain it. Oh gosh. Okay. So that is what we want to start with, right? So you can write exactly the same thing. 4.86 times 10 to the negative 2. We're going to start doing our math here. So just write that number out. We always start with what we're given. Sorry? I would. And just start down here. Give yourself some room. This is just for us to know. So we're going to come back. 4.86 times 10 to the negative 2. Nice. And then you always have to put a unit. So this is moles of helium. So we're going to just put MOL, that's short form for moles. And HE for helium. Good. And then we're using something called dimensional analysis, which means we're going to multiply it by, in fact, this fraction. So you can move that down there if you want. But I want you to start a little bit lower, right? Because how dimensional analysis works, you heard it the other days, right? Okay, so you're going to multiply this by a fraction. Do you mind? I'm just going to move you down, just because we're going to be tight. So, okay, and you can do that.
Wait, I'm very tired. Oh, I just realized I have to walk fast. It's not a high school. Hey, at least
And just don't forget what unit's going to go up here.
Wait, no, you're not a rabbit, you're a rabbit.
Grams of what? There.
I will please.
Actually, you'll find that your phone is not nice for scientific notation. Mad Darvis. Okay, if you're comfortable with it, you're welcome to it. I don't advise it. I think every time I've ever had students use phones in the past, they run into lots of trouble. But yeah, I do not recommend it. I've yet to find a good phone calculator that doesn't screw me up and doesn't make mistakes. But if you're comfortable with it, I mean, go ahead.
I am thankful that my mom doesn't let us buy Halloween costumes
Whoa.
because she likes you to be able to wear stuff underneath it, so it needs to be together. Which is why I have, look at this, I have so much room here.
It's a shame that you got no
I
marks.
feel wear like, but like all
Units.
the words, and it needs to be
Yeah, like that, but I would give you 0.
Because for this piece,
I mean, I guess I'd give you 1 because you had some units there, but all of this.
Do I need to show the last?
Yeah.
Rich, I did my cap 11.
Because again, look, I understand that it's pedantic when we're doing a 1-step question. When we do a 7-step question, you're not going to do that. You're just, right? So, yeah, we're going to show her.
I think they liked my pie. It's my No, it was a gift given to me. It's my mom.
Yeah, one thing about science is that it is occasionally formalistic. There are times when we need to say it needs to be shown a certain way. And the reason for that is we need to make sure that we're all thinking on the same page. Yes? Yeah, of course. Of course. You don't have to ask. Okay, so how would I set this up? I am, as long as it's clear and the significant digits are correct, I'm indifferent. When it is just a couple of decimal places in, if it was going to be like 0.000000003 or something, then I want scientific notation because it's hard to sit there and count the zeros. But if it's like 0.025, I'm fine with standard notation.
So
Basically,
what's the answer to this question?
I don't know the answer to this question yet, but use your common sense. You know what I mean? If it's an obnoxious number of zeros needed, then give me scientific. But I trust your judgment. How's that? Somebody want to tell me how they set this up? Sorry, did you? That's great. That's how we learn. Yeah, no, if you did it right the first time, you haven't learned anything. But if you did it backwards and noticed you did it backwards, then you've learned something. So how should I set this up? Yeah, what do you got?
Mass of helium equals 4.86 by 10 to the power of -2 molar.
What is that? So 4.86 times 10 to the -2 moles of? Good. Okay. And what do I do with that?
Multiply it by 4.00260 grams of helium over 1 mole.
Nope. Fraction. Okay. 4.00260 grams of helium over what?
1 mole.
Great. And where did you get those numbers, Alondra? Those are random numbers.
I got them
From the periodic table, because you know that 1 mole of something always weighs just what? The atomic mass, and you have to make sure then that your unit is in grams. So 1 mole of something weighs its atomic mass in grams. And once we get the habit of that, I promise it becomes easy, but it does take some repetition. This is really one of those things where some people take to this really quickly, and like 2 questions in, they're like, oh yeah, I can do this. And some people need like 100 examples, and it really is very individual. Don't be discouraged by it if you take 100 examples. You'll know it that much more richly. Now, when I do this, what units are going to cancel? Moles of helium with moles of helium, of course. And so the remaining unit will be grams of, sorry? Very good. So our answer will be in grams of helium. I can put that down before I even do any math, because I can see that just from the units. And what does the math actually work out to? Yep. 1.94 times 10 to the -1. That is true. Or you could have put what? Yep. Which?
194.
Yep. The exact same answer. And the important thing is that we say it is grams of helium, right? Because otherwise, I don't know. Maybe you have 0.194 milliliters of Coca-Cola. I don't know. How do I know? Right, so you got to tell me what it is. That's very good. And of course, did we do the right number of significant digits?
Yes.
Yeah, because here we have in the answer 3 sig figs. Up here we have 3 sig figs. Here we have, God, I don't know, 1, 2, 3, 4, 5, 6. Wait a minute, I only have 1 here. What's going on? Why is that infinite?
Because it's just a counting number.
Kira, I love that whenever I do that, you just sound so disgusted with me. You're like, ugh. Orlando, it's infinite. Ugh. Okay. I wasn't actually looking at you, but I like to think that's what you did. Okay, good. All right. I want you guys to do the next couple examples. Next couple, and I'm just going to walk around and say things like, good job, keep going, or you can do it, or show your units, Zach. You know, something like that. Encouraging things. Yeah, we'll do 2 and then take up 2.
Yeah, I know, it's really easy. That's why we have counting. Because we're nerds. How many? I'm doing this with gloves on. Oh no, my paper's already given up on me. Well, I got the camera.
I'm so impolite.
I appreciate, like, you know what else is impolite? Not showing your units. So I want you to think of that as also being really impolite.
I will remember that.
It means everything's Never was.
One I do it.
Yeah, oh, that's fine. Yes. No, in this case, because you never have 6.02 times 10 to the 20, right?
Hi.
That's a lot. Sometimes we had 6.02 times 10 to the 20 atoms. But does this question ask anything about atoms? No, so 6.02 times 10 to the 20 does anything in this question? No. And seriously, that's a great question. It's one of the most common mistakes. But remember, 6.02 times 10 to the 23 is how many atoms you have. So if the question asks how many atoms, what number are you going to have to use?
Not in this classroom.
And it may not be atoms. You could say how many molecules.
And anyway,
It would still be.
it wouldn't make any sense.
It could be how many ions.
Which I can't.
But it would be a number, counted number.
It's because.
Does that have anything to do with this question? So that's good. So what we need to know is how many grams. The nice thing is every single time.
No,
How do we get this number?
I ain't trying to say anything.
Grams would be like I'll put a and say 10 grams would
That's
be
right.
for
That's right. Very good. Yep. There are, whatever the formula weight is, whatever the atomic weight is, there's that many grams in 1 mole of.
Max of car. Dot. And dot. Is it 17 grams exactly of calcium? What's the 17?
It's 17 grams.
Well, that could be.
Is it? Can grams ever be a precise exact number? No, because grams isn't something we count. Grams is something we weigh. So it's measured. It's a measured value, which means that is significant. Those are significant digits. So how many significant digits are we talking about? 2. Dose. Good. And what?
You know, the fact that
Oh,
you
okay.
knew
So this is good.
that-
But did I give you grams or moles? Because you just put them both here. I gave you one.
No.
So our answer is going to be nope. Our answer is how many moles? So our answer is going to be, well, our answer is going to be some number.
But like,
You know exactly.
We
We don't know the number. But the answer is going to be in, what did I tell you? 17 grams. Good. So this is 17 grams. So now, I like the numbers here. The numbers are perfect. That makes sense? The only problem is, then we have grams times our which doesn't cancel. It would actually give us grams squared, which doesn't make any sense. So should I have grams on the top here? Grams should be. Okay, so the numbers are good, but you've got to switch them. So it should be 1 mole on the top and 40.0784.
Like, who said the guy's population? They just get the same.
No, when you
species,
switch these,
but
because instead
the
of
old
multiplying,
type of
you eliminate.
seeds and then like, because the other, you know,
The setup is good, the process is good. You just gotta make sure that whatever unit you start with, that's on the bottom. Does that make sense? So again, the number goes with it. It is 40.0784 grams. That number needs to be on the bottom. And it is 1 here, that number.
there are species that are not.
So do you mind if we reset it? Let's reset it. So you tell me, I'm gonna start with what?
Like, when you see like a. It looks like.
And then we always multiply by 4. Now what units do I want to cancel? So we're going. So grams of calcium. And my answer
So
is going
gloss
to
rider might not just be this,
So that's
one, but it could be a tall.
And now we need the numbers that makes this true. Well, we always know that the periodic table tells us how many grams are in 1 gram. So 1 mole is how many grams? 1 mole weighs how many grams?
This is crazy big number that nobody likes.
You can read that.
You're crazy big number.
I'm gonna believe you. And now you can do that.
I was making that back.
But you see how I say it out loud? Then that's how I say it out loud. You can kind of whisper to yourself.
I told you.
I could have randomly.
Put your hand up if you want.
You don't listen to me today.
I'm tired.
And then you find out, say, oh, well, I
What's
didn't.
going on, Ireland?
Are you
How we doing?
tell me this?
Okay, so here's how we always start. In the question, they've only given us one fact. They've only told us one year. What have they told us?
Yeah,
Of?
that's pretty much all.
Perfect. That's how we start. It's 17 grams of fat.
Okay, I don't know how to put that in that, so I will go there.
That's always how we start. We start with what we're given. And now we're always going to multiply by a fraction. We're always going to multiply. So you can put the multiplication sign and the fraction. Just right there. No, just fraction. Now we're going to think our way through. What unit do we want to cancel? So where in this? Don't worry about this one. So where in this fraction? Good, so put that.
Okay, what do you want to say and see?
Oh, no. We're not going to use that number. When you set these up,
Yeah, I forgot to.
always just work. We're going to reset. Also, we're going to get to a pencil. I like making mistakes. Multiply by a fraction.
That's correct.
Okay, so we want to always start the question like it's just as easy. What you know, and now for this, we're just going to put unit we want to cancel. And just leave room for them. Grams of. And what the question wants to know.
No, pencil come back.
I need unit up top. Not necessarily, I mean, you're right. But now just focus on the now we need to know how many how many grams of the nice things you can always find.
How come it's so much of a week?
Oh, no, I forgot. So let's look at calcium.
It ran a week for me, that's what it did. Hey.
You're graced with your presence.
I saw it.
Good. Now do it. No problem.
I'm having trouble loading. I was doing something with my grade 9 class because we're having a little more of an update, so I was putting stuff in.
Sure.
And I was updating the class, and now I have an error. Am I able to
Just
switch?
switch it up. Actually, while you do that, I'm going to do my attendance because I am a responsible teacher. So are you too cold? I like it cold because I'm, okay, wait. Yeah, right up there.
I'm going.
Oh, I can't do my attendance.
Because I'm.
No, because I was going to do it on here, but it's broadcasting live over the internet, so I can't be broadcasting my attendance live over the internet, can I? That would be inappropriate.
Inappropriate.
It got real quiet real quick.
What time is it? Oh, there goes that theory. 10 to the hour and 10 after the hour.
That looks great.
Does it mean it's right?
I don't know if it's right.
Oh.
What do I look like? The number.
But your penmanship
I
is
can look
lovely.
at 9-digit numbers and tell if you multiplied them correctly off the top of my head. It seems reasonable. Can I ask? It's not wrong. I'm just curious.
got it.
Do you do this step just so you know what function the calculator without all the letters? Why is that?
I don't know. Yeah, just to have it.
Okay, I mean, it's not wrong.
Alondra, are those PJs? They're awesome. I love them. They look warm and fluffy. Well, I can see it. It looks like it would be.
And the best part is the gloves can come off.
Ooh, nice.
I give
You realize that the second Kayla sees you today, you're gonna turn into a giant teddy bear.
Yeah.
What?
There's a second Kayla.
Yeah, that looks great.
There's
What
a
was the
second
unit?
Kayla. Second Kayla. I don't know who's Kayla.
I said, you realize the second.
We're gonna start with that.
Oh, I was thinking like the second
I get
Kayla.
it.
The other one that we
But,
know.
yeah.
I don't know these.
Look,
The second Kayla sees you.
it's my grade 9.
I'm expecting file it every time to load.
So then, when I go like this, it does back up.
And have you tried that?
No, I haven't.
Well, I would press cancel for now.
Let me guess, you have a 5?
Wow. Try okay? I mean, my concern is that you're backing up something that's corrupted, but I guess that's not going to change it. Try okay, see what happens. That's
Really?
weird. Yeah.
Okay, so I've gone, I was working on it,
Yeah.
and then it kind of froze and I went close program.
Yeah, and now it's
It's
corrupted. I feel like
Is it corrupted?
it looks like it, but I feel like,
So what do you think I should do?
well, let me talk to Mr. Calford. He knows a lot about this stuff too, and I'll see if there's a protocol for that.
Because
And there's a lot of rounding, so I need your help.
Sorry?
The rounding is confusing me.
Yep.
So, because of the fact that, yeah.
Okay, I'm here to
So
help.
this would round up to a 5. Would that make this round up to 70?
Okay. So what you do is this.
I'm confused. Yes,
What are you rounding to? The 9?
yes, because I need your 6.
Don't do this like chain rounding. If you're rounding to the 9, just
Use
look
the
at the
4?
one number next
Okay,
to
so
it.
then it would just be 6.
Yeah, if we're
That's
doing
right.
chain rounding, it definitely
Yeah, we don't do that like, well, this rounds that and that rounds this and this rounds that. You just look at the number immediately next to it. I'll talk to Tim.
there is a restore, which says restore a class from a backup. Unfortunately,
How old is your backup?
the last time you and I did.
Okay, so let's hold off on that because it may be that we can go in and see what the actual error in the file is, fix it. I'll talk to Tim at lunch and we'll
So I'm gonna go and tell Mr. Matola because he
Yeah, do me a
wanted
favor, though.
workbook printout. What?
click that.
What's that?
Just click it. Oh, not that. Click that.
Snipping?
Yes.
tool?
Yeah, now click in here. Oh, one sec. Click in here.
Right here?
Okay. Now new snip. New. And make a picture of that. Just click here and drag along. Yep. Other way. Yep. Other way. Let go. Great. Edit. Copy. We just took a picture of your error. Now I want you to go into first class and email me that picture. So go into first class and start an email to me. Just trust me. Go to first class.
Do I close these out?
Leave them open. Okay, guys. I want to take a look at this one. How many moles in 17 grams of calcium? How should I set this up? Actually, before I set this up, what information do I need to know about calcium? Very good. And what is the atomic mass of calcium? Yeah, please.
40.
Great. And that is grams per mole, right? And I'm just going to make sure I know that when I start my question. Now, again, for these, it feels like a waste of time because you could just check the periodic table. Eventually, for the ones where we can just check the table, we won't write them down. But it's good practice to get in here so we know where that information is coming from. I got from the table. How do you set this question up? Anyone? Yeah.
So they have moles of calcium equal 17 grams of calcium.
So we start with 17 grams of calcium. And then we're going to multiply by a fraction because that's how we do dimensional analysis. What am I going to put in my fraction? Yep.
On the top or on the numerator.
Yep.
Put 1 mole of calcium.
Okay.
And on
The bottom.
the denominator side, you put 40 decimal 0.784 grams of calcium.
Perfect. Now, I would like to get in the habit, that's all right, like it's completely good. I would like to get in the habit of putting our units down first and then putting numbers. And the reason I say that is sometimes we get a little trigger happy with the numbers. It's a good habit to get in to know where my units go first and then put the numbers in. But if we say this out loud, it makes perfect sense. 1 mole of calcium weighs 40.0784 grams. Does that number seem reasonable? If I said 40 moles of calcium weigh 1 gram, would that make sense? And again, I cannot stress this enough. The more often you say it out loud, the more correct things start to sound right to you and incorrect things start to sound weird. But that doesn't happen if you don't actually kind of whisper it to yourself. So I want to see you all looking a little bit psychotic, saying they're going, calcium, 74 grams. That makes sense. All right, that's what I want to see. I want to see that. Because listen, it's easy to go, I'm not going to do that, that's embarrassing. But the fact of the matter is, These are learning tools. Verbalization is a way we learn. We learn when we speak things. Writing things down is a way we learn. So when I give you these tips, I'm not doing it because I love giving you advice that you'll never take. That's why I tell my children to do things. In your case, it's because it really does help. So I encourage it. And what units will cancel here? Because we're not finding mass here. What are we finding? That's a good question. I was going to mention it at the end. The question is how many moles? And in chemistry, the letter N stands for number of moles. It's just because if you used M, that's the same letter we use for mass. So here, N stands for number of moles. That's a good question, by the way. What units cancel here when we do this? Grams of calcium cancels with grams of calcium, which means my answer is going to be in what unit? Moles of calcium. Very good. And what is the answer? Yep. What do we got? Should be like 0.4 something, 0.41, 0.42. What is it? 4.2. Well, what's the answer? 4.2. And why is it 4.2? Yeah, 2 significant digits. Because, of course, this has 2 sig figs. This is
infinite.
Yep. And this down here is, I'm going to assume that's true. I said I'm going to assume that's true, and then I put the right answer. I didn't mean to do that. I wasn't trying to be rude. I just counted in my head, then convinced myself you'd said that, and then, yeah, so I'm sorry. I legitimately was not trying to be snarky there. Though snark is just kind of my default position at this point, I guess. But, sorry. Yes, that is also a wonderfully correct answer. If you said 4.2 times 10 to the negative 1, not only would you still be correct, but I would applaud you for your wonderful use of scientific notation. In fact, I applaud you for your wonderful use of scientific notation. That's correct. Now, in this case, they both are completely legitimate answers. So
It's down here.
yeah, so we can just, whoa, oh gosh, oh golly. Oh, it's not a touch screen. I was trying to touch it. It's not a touch screen. There you go. And you can just send that to me. You're welcome. And we have time to take up one more. Yes. No, do you have a question? Please. Okay. And we'll take this one up here. By the way, this is not a lot of neon. This would be too small to measure. There isn't a measuring device in the world that can actually measure 3.42 times 10 to the negative 11 grams of something. Is that true? That's not true. There are hypersensitive specific things that can do so in a lab. But there's not a measuring device that you will come into contact with in your high school career that could come close to measuring this. But that's okay. We can still do the question. How am I going to set this up? Yep.
You can start off with 3.42 times 10 to the negative 11 grams. Yeah.
Very good. And of course, I put a little N of neon out front. What's that N mean again? Number of moles. Yes, that's just what I'm finding. Great. And what am I going to do with this? Be specific. Very good. We're going to multiply it by a fraction. Hopefully your fraction line doesn't look like mine does, which is that it's been beat up by fraction bullies that came around and said, give us your fraction lunch money. And he wouldn't, so they beat him real good. Okay, what am I going to put on here? Yeah. Great. And I like that we're focusing on units first. Why did you put grams on the bottom? Yeah, that's what we're given, and that's not what we're finding. It's what we want to get rid of. We don't want to know about grams. We already know about grams. What I do want to know about is moles. And now that I've done that, what numbers go here? How many grams are in a mole of neon? Like from the periodic table? How much?
20.1797.
Great, like that.
I won't know.
Why am I switching it? I like this. I want to be like this.
That's not how it works.
Why not? It works for me. I put the numbers there. Yeah, someone say this out loud for me. Whoa, Snorkelpotamus in the corner. Okay, I will. 20.1797 moles of neon weigh 1 gram. That doesn't make sense, does it? That isn't what I think. I'm just being difficult. So I would say 1 mole is, what is it? 20 point what?
I think we should have done this with the other round, so you could have just seen how much.
Okay, and then you raise a good point. What does that actually give us? 1.67?
It's 9, but it only round.
1.69, okay. 477. And how many significant digits am I keeping here? Just give me a sec. So we're going to look at this 9. Does it round up or down? It rounds down. And what's my unit?
That's not right.
Do I need some scientific notation?
Yeah, it's times 10 to the power of -12.
Very good. And the unit is? Moles of neon. All right. I want you to finish yesterday's homework and today's homework. You guys are doing very well. All right. This is a tricky concept. You really are doing very, very, very well. I'm proud of you, but you have to practice. You got to practice. You gotta.
It's so get annoyed if I'm really practice, and I'm like, I know it.
I know, but listen. You don't think like Michael Jordan knows how to shoot a layup, man? Like, yeah, he does. But guess what he does? He practices. You don't think that Zach Brown knows how to play the C finished scale? But guess what he does?
No,
He practices.
my pumpkin, no.
Sorry?
My pumpkin.
Oh, sure.
Awesome.
Oh, thank you.
No, you took away my pumpkin.
Oh, and my cousin.
I was going to bring my airsoft gun, and then I thought, is it no weapons? I thought, is the bullwhip a weapon? I'm good.
Don't take it
I have to put this
Is that
back
it?
on because
So like if I were to lift Caitlin, would that'd be wrong?
I wear this freaking hat that you want to slap me or run me over.
Oh, and April says.
Don't
What's April doing?
Oh, she's doing good.
Yeah, please, guys, dig in and have as many tidbits as you like.
Piece of chocolate.
Oh, no.
Yeah, wait,
Let's go run away right now.
I gotta get my heat.
Chloe, you look adorable. Thank you.
I'd get this back in here.
Yes.
Yeah.
Right, Alondra, you're taking me back forever, and you're trapping me in. 2 things I do the best.
Wait, my pumpkin, no! I don't.
No, I
No. Yo, I have the best.
No, it was yours while you were in here.
I like the
Oh, that's right. What's it called? And the mall. Yeah.
Jimmy fell off the stairs.
It's like I was walking and got caught in my shirt.
Yeah.
Oh my
I was actually thinking like Bob Jones and Indiana Jones' significantly less successful younger brother.
Bob.
Yeah, it's like a name tag. He like just has a master's in history and he like keeps the community solid. And full back. The one you sang, right?
Oh yeah, that
Yeah, yeah. Oh, that's so funny. I don't know the musical.
Actually, the sweater he wears is the drink.
Oh, really?
He usually wears the red sweater, but he wears this sweater. It was at a Halloween party. Oh, you know Orlando.
That was good.
I love your
I
costume.
love you.
Mr. Orlando, the thingamajig. Mr. Orlando, the intercom was. Oh, no. Smells like blueberry bagels in here. Toasted blueberry bagels.
Calm down.
Do you eat it?
Dude, why did you do that? You should wash it off.
I know, it's so itchy. I need it to hit point, so I didn't think about how itchy it was.
Ooh, it says pie. There you go. And it's pretty cute. It's pretty cute, so I call it a cutie pie.
Yeah, I didn't shout at Mr. Orlando, the thingamajig.
Oh, that was so descriptive of you.
I can't.
Are we doing a live? No, not today.
We're doing spooky things. Yeah, right? We're doing spooky things. You never started.
Remember how you
It's
told me?
culminating.
Richard, I have to do that thing that is better than when I have
Yeah, you're gonna.